Good day, folks. This is tutorial number 4 in a playlist that I'm preparing for performing a kinematics analysis in the 3D Experiences platform. Uh, I want to remind you that the kinematics solver is actually the CATIA DMU application or workbench. Okay, so the tutorials one, tutorial one was actually a general introduction to the content of the playlist, and tutorials 2 and 3 were solving a problem where a block was accelerating along a track. However, I did it with two different ways. In tutorial 2, I used a formula, essentially, or excitation law, as it's referred to in 3D experience. And in tutorial 3, I use segmented excitation. What I like to do in this tutorial is a different approach, where I actually provide this graph as the way the kinematics proceeds. In other words, when time is less than, for example, 2 seconds, the well, it starts at 0, 0, and then as time goes on, the position of the block along the track increases. It goes to 16 inches, and then between 2 and 4, it sits put at that location, and then after 4 seconds, between 4 and 6 seconds, it drops down linearly, and it goes to 12 inches. Okay, now this can be done with the segmented excitation approach that I did in tutorial 3, but I want to do it a different way. I want to use this sketch law excitation, where you actually give this curve somehow, or basically it's a sketch, give this curve to 3D experience, and then ask it to follow that essentially prescription. Okay. Now, of course, one option is to create that sketch pretty much exactly like it is and give it to 3D experience. Don't worry about the fact that the scale here is uh, second and this is inches. So when you create a sketch, oh, we're going to use the ordinary length, but we'll see that. This is one option. The other one is to scale it. If you feel that maybe this doesn't fit, this is too big as far as the rest of the model is concerned, you can divide by appropriate scale. For example, what I've done is I've taken this entire vertical axis and divided it by 4, and the horizontal axis, if these are the numbers, divided by 2. So what I'm going to do is actually this information, the one on the right, instead of the one on the left, or any other scale that you want, or in fact, if you insist, you can actually give the one on the left. Now, when you do that, when you scale them, somehow, first of all, you have to tell the 3D experience what is the time scale what is the total time on which this law or this curve is to be applied to your kinematics calculation. That goes in here, okay? You can make it 6 seconds. That's what I want. So uh, the total duration, this has nothing to do with the time scale. It's just that this law, I want it to be applied over 6 second total time. Okay. Then you have to say, how is the vertical axis scaled up? So that you have to go to once the law is created, you go there and you can change the scale. You, you'll see that. I think over here there is a mistake. This should be 4. This is 4. Yeah, excellent. Because if you look at it there, you see the scale was 4, and if we give that curve, we have to multiply things by 4 to get what we want on the left side. So this is a typo. All right, let's move on. Now, once you do that, you can actually plot it. Make sure you do not make a mistake. So this total height will be 16. Uh, this will be notice that the law that I gave it is this, and beyond that, it's taking it to be constant. That's fine. Now, the idea behind this playlist is that I did a tutorial book back in 2016 using the version of the 3D experience that was available there, but I've not updated that book. So instead of updating that book after 8, 9 years, I decided to go through all the chapters and basically uh, do it as a video tutorial. Okay. All right, let's go ahead and do this. Okay, so we are in 3D experience. And this is, remember I told you that the kinematic solver is actually the CATIA kinematic solver. Okay, so what we're going to do is create an assembly here. I'm going to insert my first, 3D part, and this is going to be the track. Okay, now of course I can rename it and things like that, but that will not be necessary. It's not the point of this exercise. So okay, there we are. This is going to be my track, so I'm going to double click on this, double click on that to make that actually track. Okay. Okay, we are in part design. So on that vertical axis, a vertical plane, I'm going to sketch a 1 by 1 uh, square. So I'm going to pad it by 21 inches later on. Okay. This is one. All right. Exit. Pad it by 21 inches. Okay, so that's going to be the track. And then I'm going to go up here all the way to the top, right click, insert another 3D part. That's going to be the block. So let me make the block. I go to part design here on a convenient plane. On that vertical plane, I will sketch a 1 by 1 square. You mentioned these things. Okay, this is also going to be 1. All right, exit and pad it by 1 inch. Okay, that's going to be the block. Now, all the way to the top, I want to put this thing at the right spot here. So we are in the assembly design. So, and I don't want to create any assembly constraints. So I can use the snap icon on the manipulate snap icon. For example, say I want this thing to go to that corner. Okay, good. Very good. Now we're going to uh, uh, remember, I have to give this curve, the scaled version, I decided, somehow. Now, this can be done in a separate part, or it can be done in the block, it can be done in the track, or it can be done in a arbitrary 3D shape that you can create here. And let me actually do that. Because in tutorial 5, what I'm going to do is 2 blocks racing against each other. And that's how I'm going to do that. So I might as well go ahead and do that here. It is possible to make that sketch that I showed you in the track or in the block, but I'm not going to do it like that. So I'll go all the way to the top, right click, insert, 3D shape, 3D shape, and notice that it's created here, and its sole purpose is to hold for me that graph that I want. So let me go ahead to that, for example, vertical axis. Let me go to part design, go to that vertical axis, sketch. Okay, so what I want to do is this graph. Okay, now notice that my units are inches, so when I draw the horizontal axis, it's not going to be second, it's going to be 1, 2, 3 inches, and this way it's going to be that. So the only thing is that the only restriction is that notice that you have a local axis. So the if you're going to put this thing in there, that axis must be lined with the horizontal axis, okay, in the same direction. So this way time is increasing, this way obviously uh, h is increasing. Now it can be done anywhere, so I can draw it here or I can draw it there. It really doesn't matter. Just for the sake of argument, I'm going to do something like that. I'm going to start here. there, there, and there, and I'm going to put the appropriate dimensions. Okay, so when you look at this, from here to here is 1, from here to here is 2, and then 3. Okay, so let's do that first. So dimension from this point to that point, horizontal. I'm going to make this thing 1. Another one from here to here. Once again, horizontal. This is going to be 2. And finally, from here to there. Start again. From this point to that point, horizontal. And that's going to be 3. And just the vertical axis that I have to fix. So from this location to that location, horizontally or vertically, is going to be 4. And dimension from here to here, and once again vertically, this is going to be, I can't remember, it's going to be 3. Okay, so that's going to be 3. So this is the non-dimensionalized scale that I'm going to give to the 3D experience, but later on I have to tell it that vertical axis should be scaled by factor of 4 and horizontal axis by a factor of 2. Okay, that's fine. Okay, let's go back here. This is all gone, exit. And notice that this sketch is created. It could have been anywhere. I decided to put it in the dummy shape holder right there. You can see that, it's right there. And fine. Now let's go back to the assembly right there, because I want to create my constraints, joints. So you go to engineering connection. First of all, let me fix that track. This is the track. Okay, it is first. It is fixed. You can see that. And then I want to create a prismatic joint. There's a prismatic joint. Okay, and I'm going to use this template, edge and edge, plane and plane, coincident. And then for the offset, for the command, I'm going to be using the offset between 2 end planes. So this one, this is exactly how I did it in tutorials 2 and 3. Okay, so this edge and that edge, this plane and that plane, you can see that I'll pick. And for offset, I'm going to use the distance between this plane and this plane is going to be used as a command later on. Right now it's 0. Notice that I can change this thing. Okay, so let me put it back where it was. Okay, good. All right. And let me say okay. I don't want to do any contact, so that's fine. Okay, good. So the prismatic joint has been created. Okay, good. So now we're going to go to uh, mechanical system design. This is where we create our mechanism and things like that. We're going to create our mechanism representation. The second tab is already all checked by default, so that's fine. I'm going to create a mechanism here. Notice that it is created right there. You can see that. You can see that. There are 2 joints, fix and prismatic. And there's one command, and this is the offset command that I have. Now, I don't want this block to go that way. There's several ways of fixing this thing. You can either go there, go to this line, you see that? Go to this line, the command, right click, reverse orientation. That's one way of doing it. The other one is select this, flip the direction, either way. Because I noticed that on one of my computers, I don't get this black arrow. So but I can always go to the command and do a right click and reverse direction. Okay, good. Now, let's go and check this out. Okay, so we go here to the mechanism player. Time. Okay, notice that if I drag this thing to the right, this should move to the right. But that's because I flipped the direction. And if I move it to the left, it should go to the left. because I flipped the direction. That's the way I want it. So it is working pretty much the way I want it. Now, we're gonna go to mechanical system, not design. We're already there, but experience. Uh, we're gonna create a scenario. Okay, or mechanical simulation. Let's say we're trying to create a mechanical simulation. Notice that here is a tab that was created, mechanical or kinematic simulation, and a couple of things. Notice that we can create our sketch law. Remember here, this was based on sketched law excitations. Let's go create that. We're going to click on sketched law excitation. It says, where is your command? Basically, it says, where's the command? Well, the command is, if you look at the branch which says mechanism representation, these are the join, and there's the command right there, right there. So if you click on that, it's going to put it in that box. See that? There it is. This is where's the sketch? Well, the sketch was over here, right there, right there. See that? This is the sketch that I created. Or if it's making it easier, you can go to your the tree from that dummy 3D part that I put in there, either from the tree or from here. You select that, sketch one, and this is where I want to define the total time, because right now when 3D Experience look at this graph, it sees a horizontal axis, but it doesn't. This is supposed to be essentially time. It doesn't know what this thing. I want this thing to represent 6 seconds. You just put the 6. Okay. Now, if you want it to be over a 10-second period, then just put a 10 there. Okay. But I want it to be 6. This is how my graph was originally defined. So that's what I'm going to do, 6. And then we say, okay. Now, notice that this was created right there. I see on the in part body, where I put my sketch, this was not there. It just created. So if you double click on the scale, you can say, you know what? What you see there is 4. What you see there is a height of 4. What I really want this thing to be 16 inches. So if you double click on this, you make this thing factor of 4. That's where the vertical scale comes into the picture. We say, okay, very good. And that's pretty much it. So let's go back to the scenario. Let's go back to the scenario. We created our excitation. It's right here. You can give it meaningful name. For example, later on in tutorial 5, when I do a block, green block and blue block racing against each other, I will give these things names that I can identify. Now, we go here and do kinematic scenario right there. See that? Kinematic scenario. Excitation was created. I want to use it. Reference. The total time, you decide what you want it to be. Do you want to do this thing over a 10-second period? Do you want to do it over a 6-second period? That's entirely up to you. Okay? So let me make it, all right, 6-second, end of the time, 6 seconds. And obviously I'm going to use a lot more frames, so I'll put down 0.05 to have 0.05 to have more than just you know uh, 2 or 3 frames. Essentially, this is a number of frame, will be the number of frame, and we say okay. Now let me also plot the velocity of one of these corner points. To do that, I go to right here. I go to Pro, Position and Speed. I select that corner point, and I want to get the information about that corner point, velocity of it, acceleration, position, etc. later on. Now, if you double click on this, double click on this scenario that I just created, notice that the probe is already put in there. I don't have to do that, so that's good. Now we go here to this icon. You say compute and generate results with global update. That's fine. I'm going to click on that. Okay, all right. So let's see what we've got here. Uh, well, first of all, if you go to plot, well, you can animate this thing as you see fit. So let me play it. This is okay. It's playing over and over and over. Okay, so let's do it ourselves. Let's go back here. And the next step is oops. Let's go back here. Let's do this. Put it back where it was. Okay, let's move it ourselves. Okay, moving. It will go all the way to 16 inches, which is going to be somewhere around here. 16 inches. After 2 seconds, right? 2 seconds. Watch this number here, 2 seconds. It's going to go there and sits there for 2 more seconds. Okay, so it reaches the 16-inch location right there. And then it sits here for 2 more seconds. Okay, I can put down 3.8. Still sitting there. But 4 still sitting there. Okay, but when I do 4.2, it's going to move to the right. 4 point, I don't know, maybe 4. Oops. Okay, so let me actually move it there. See, moving to the right, and it will go up to 6 seconds, and then it's going to essentially stay there because that's the end of the excitation. Remember, I made it 6 seconds. Remember that? Total duration 6 seconds. So basically, this is going to be the end of the excitation right there. There. That's the end of the 6 seconds. Sits there pretty much. Okay. Now, this is it. This is a simulation. Okay. Now, a couple of things that I want to point out to you. Let me get rid of this. If you click on this view scenario results, deselect everything. Show me two things. One of them is, first of all, the scenario law. Remember that sketch-based thingy? Plot. So this is what I have, right? 16 seconds sits there and then it goes there. Now here's the graph. So this graph is this graph. Okay, here's your 12. Here's 16. Uh, here's your 12, etc. Now, the other thing we can do is that we say, all right, show me the position of the vertex, that position that I used probe to define it, right there. They're sitting on top of each other, obviously, because the position of that vertex is going to be the same as the command. So if you go here to the specification and say, don't show me the first one, just show me the position, it's right there. And that 0.05 that I put determines these number of these dots that have been created here. Now, something else that I want to do, I pointed out that if you want to make sure you haven't made any mistake, you can actually plot these things. So right there. So so you can put the cursor here, right click. You see. Okay, so what we're going to do is let me make sure I'm in the right spot. Okay, go to scenario. I went to scenario. I didn't want to mean result. Put the cursor right there, right click, plot excitation, and this is what you input it. Okay, it was a good check before I actually ran it. That's pretty much it. So what I'm going to do in tutorial 5 is to take this problem, make it a bit more complicated. There are two blocks, a green one and a blue one, racing against each other with their own sketch law excitation. Okay, good luck.